pump with the bands. Pump with the pump with the put the pump pump with the bands. Pump with the pump with the put the pump pump with the bands. Pump with the bands. Pump with the bands. Pump with the pump with the put the pump pump with the bands. Pump with the pump with the.
Pressure is something we experience every day, from the air around us to the ground beneath our feet. Picture out a balloon. When you blow air inside, it pushes against the walls of the balloon, and that is air pressure.
Another is truck tires. Tires are filled with air pressure. It supports the weight of the vehicle.
In physics, pressure is the amount of force applied on a certain area. The formula for pressure is P equals F over A, where P is pressure, F is force, and A is area. The unit of pressure is the Pascal, written as PA. It was named after Blaise Pascal. 1 Pascal means 1 Newton, a force acting on 1 square meter of area. Pressure depends on two things. First is the amount of force applied. When the force increases, the pressure also increases. Second is the area where the force is applied. If the area is smaller, the pressure becomes greater. If the area is larger, the pressure becomes smaller. That is why a sharp knife can cut better than a dull one, because the sharp edge has less area, so it creates more pressure when cutting.
Now, let's talk about some real-life examples of pressure.
When you wear high heels, your weight is focused on a small area, which creates more pressure on the ground. That is why high heels can sink more easily into soft ground compared to flat shoes.
Another example is using a knife. A sharp knife has a thinner edge, so it applies more pressure and cuts things easily. A dull knife has a wider edge, so it creates less pressure and it becomes harder to cut.
Broad handles and bags and suitcases are provided for the comfort. Broad handles have large area, so the pressure exerted on hands and shoulders would be small while carrying the bags and the suitcases.
Pressure affects many things around us, from how knives cut easily to how shoes and straps spread weight, showing its importance in our daily lives. Here is a simple example problem. If a force of 10 newtons acts on an area of 5 square meters, we can find the pressure by dividing 10 by 5, which equals 2 pascals.
Now, let's talk about the variation of pressure with depth. Pressure increases with depth because of the weight of the fluid above. The deeper you go, the greater the weight of the fluid pressing down, and as a result, the greater the pressure that you experience. The density of the fluid also affects the amount of pressure. Denser fluids, like seawater, exert more pressure than less dense fluids, like fresh water, even if they're at the same depth. That means if you dive into the ocean and a lake at the same depth, the pressure you feel in the ocean will be higher because it is denser. We can calculate this using the formula P equals RHO times G times H, where RHO stands for the density of the fluid, G is the acceleration due to gravity, and H is the depth. This equation shows that as either the density or the depth increases, the pressure also increases. Now, let's move on to atmospheric pressure. This is the kind of pressure that comes from the air around us. Atmospheric pressure is the force per unit area caused by the weight of the air above us. At sea level, the standard atmospheric pressure is 101,325 pascals, or simply 1 atmosphere. This means that above every square meter of Earth's surface, the air weighs about 101,325 newtons. We do not feel this pressure because the pressure inside our bodies balances the pressure from the outside. As we go higher in altitude, like on a mountain, the air becomes thinner and there is less air above us. Because of that, the atmospheric pressure decreases. This is why it is harder to breathe in high places. The formula for pressure in a fluid is P equals P times G times H, where P is the density of the fluid, G is gravity, and H is the height or depth. This means that the deeper you go in a fluid, the greater the pressure. For air, the higher you go, the smaller the pressure.
Some examples of atmospheric pressure are when you drink using a straw. When you suck the air out, the air pressure outside pushes the liquid up the straw. Another example is suction cups. When you remove the air inside the cup, the air pressure outside pushes it against the surface, which makes it stick.
Let's try a short activity. Hold a sharp pencil between your two fingers and press it gently from both sides.
Now, you will notice that one side leaves a deeper mark. That is because the pointed end applies more pressure since it has a smaller area. This shows that a smaller area results in higher pressure.
Pressure affects many things around us, from how we walk and breathe to how fluids move in nature and in machines.
To sum it up, pressure is the force divided by area. It increases when the force gets stronger and decreases when the area becomes bigger. Atmospheric pressure is the pressure caused by the weight of the air, and it gets smaller when we go higher above the ground.
That's all for our topic. We hope you learned something new about pressure.